Hi guys. We are getting ready here to look at our practice test for chapter 8. So here we go. We'll dive right in. The first one says the graph of g of x equals ax squared opens downward and is wider than the graph of f of x equals x squared. Which of the following could be the value of a? Guys, there's two words that are really important here. The word downward and the word wider. And what I know about down is our a is negative. And what I know about wider is the A is less or is between 0 and 1. And so what I'm looking for is something or an answer choice here that is both negative and is between 0 and 1. And so A, that's negative, but it's not between 0 and 1. But B is negative and between 0 and 1. C and D are both positive, so it looks like B is my best choice. Number 2, what is the vertex of the graph of the function f of x equals 2 times parentheses x minus 4 squared minus 1? What we notice here is this one's not written in standard form, it's written in vertex form. And so vertex form, our two numbers that we need are right there. The one that's trapped, that deals with the x value, and the one that's outside and free deals with the y value. But what we have to remember is the one that's trapped. Remember, when it's trapped, we go opposite the sign. So since it's negative 4, we would write positive 4 and then negative 1. In other words, this function graph is moving to the right 4 and down 1. Number 3, which of the following functions has a graph with a vertex that is a translation 3 units horizontally to the left of the vertex of f of x equals x plus 1 squared minus 4? Now, this one can be a little bit tricky. And so what I find helpful is I take a look at this and I say, okay, this graph here, I'm just going to draw a quick sketch. A typical parent function goes through the 0, 0, but a plus 1 means it's moved to the left 1 unit, and a negative 4 means it's moved down 4. So the vertex of this graph right here, f of x, would be here, and the graph would look something like this. So now, if I want to go 3 units horizontally to the left, that would be 1, 2, 3 more places to the left. And so if I want to go 3 more places to the left, that means I've actually come over here to the negative 4. Well, the negative 4 would look like a plus 4 inside my equation. And it's not asking me to go up or down any, so I'm going to leave it at that negative 4. In this case, I think my answer would be C. Number 4 says identify the vertex of the function y equals x minus 1 squared minus 4. Again, because it's in vertex form, I can just find that vertex by saying it's the x and the y value. X is the one that's trapped. Y is the one that's outside by itself. However, remember the one that's trapped, we have to go opposite what it says. So since it's negative 1, we're going to write positive 1. And the y value stays the same, negative 4. All right, next question says, now the graph of the function, or the graph of h is a translation 4 units to the left and 7 units down. Write that function in vertex form. So we're going to write the function h of x is equal to, now because it's asking for vertex form, I'm going to go ahead and set up my vertex form and say x. Now, 4 units left. I know that's the one that goes inside with the x because left and right go with the x. If it's going 4 units to the left, I would think that was minus 4, but remember when it's trapped, we go opposite, so it would be plus 4 inside. And then I'm going 7 units down. That number comes outside where we're outside and free, and because it's down, I'm going to have a minus 7. So my vertex form would be h of x is equal to parentheses x plus 4 squared minus 7. Number 6 says, what is the axis of symmetry of the graph of the function f of x equals negative x squared minus 6x plus 8? This one I notice is in standard form. And so standard form, if I want to find the axis of symmetry, I take x equals the opposite of b divided by 2 times A. So in this problem, since it's in standard form, A, B, and C are right there in a row. B looks like it's negative 6, so the opposite of B would be positive 6. A looks like it's negative 1, so 2 times A would be negative 2. So 6 divided by negative 2 would give me an axis of symmetry at negative 3. And that's all 6 is asking me to do, is find the axis of symmetry. Number 7 says label the following things on the graph below. Guys, you can either do this with words or you can use the letters there that are written. And so A says the axis of symmetry. So I have to remember, what is the axis of symmetry? Oh yeah, that's that imaginary line that's drawn to show where the fold line is. And so I'm just going to go ahead and kind of draw that in there, and then you can either put the words out to the side or just put a letter A there by the axis of symmetry. Next, it asks for the vertex. The vertex is that point, either the maximum or the minimum point, where the graph changes directions, and I see that right down here, so I'm going to put that point there and label that B as the vertex. C asks for the x-intercept or intercepts, and intercepts are where the graph crosses the x-axis. And I see that that actually happens in 2 places on this one, so I'm going to label both of those points C. D asks for what is the x-axis, so the x-axis is this one right here, so that's the D. E asks for what is the y-axis, that's this one here, so I'm going to put the letter E there. And finally, F stands for the y-intercept. And although we may not have talked about this one so much, y-intercept, well, if x-intercept is where the graph crosses the x-axis, then y-intercept must be where it crosses the y-axis. So I'm going to label that one F. All right, moving on. Question number 8 says, does this data suggest a linear, a quadratic, or an exponential model? So if I'm going to look at this, the first thing I have to do is look at the x values and make sure that they're moving in a consistent manner. And so when I look at the x values, I'm going up 1, up 1, up 1. So that means that I can now consider the y values. And so the first thing I'm going to do is look for a common difference. So from negative 36 to negative 6, I added 30. And from negative 6 to 16, I added 22. And from 16 to 30, I added 14. That is not consistent with a common difference. So that is not a linear equation. So now I look for the second difference and I say, okay, between 30 and 22, this time I subtracted 8. And between 22 and 14, I subtracted 8 again. Since those are consistent, that suggests that this is a quadratic model, or that a quadratic model would best fit this data. Now, another way I can look at this is I can consider a graph, and I can come to negative 2, negative 36. So that'd be way down here. Then negative 1, negative 6, that'd be more like up here. 0, 16, that'd be way up here. And 1, 30 would be way up here. To be real honest, a graph in this case may not be a good thing because it looks to me like that could be linear. They just didn't give us enough points in this case to really consider. And so looking at it algebraically, the first differences, second differences, or is there a common ratio is a better way for me to tell on this one. Question number 9 is the same kind of thing. Does the data suggest a linear, quadratic, or exponential model? So the first thing I'm going to do is look at the first differences. So from 5 to, or actually, sorry, I should first start by looking at my x's and make sure they're consistent. So 0 to 1 is 1, 1 to 2 is 1, 2 to 3 is 1. Yes, they are moving in a consistent pattern. So from 5 to 25, I added 20. From 25 to 125, I added 100. And from 125 to 625, I added 500. Okay, those are not consistent, so this is not a linear pattern. So next I'll check quadratic and I'll say, okay, from 20 to 8 or to 100, that's adding 80. And from 100 to 500, that's adding 400. Again, not consistent, so that would not be considered a quadratic. So the last one I would look at is this exponential model, and that one's a little bit different. This time I'm looking, is there a common ratio? So from 5 to 25, oh yeah, I multiplied by 5. From 25 to 125, I multiplied by 5 again. And then from 125 to 625, I multiplied by 5. And since they are all the same, that tells me that an exponential model would be a good model for this data. Again, sometimes, guys, I can graph and I can see this. These would be pretty large numbers to graph, so it might not be super evident, but that is, this algebraic way does give us that idea that this is an exponential model. All right, the last two questions on our test today are asking us to graph. And so we look at this graph, and the first thing I need to notice is that this equation is written in standard form. Now, depending on if it's in standard form or in vertex form, that tells me how I need to go about graphing. So this one, because it is in standard form, the first thing I'm going to do is find the axis of symmetry. Axis of symmetry is found by taking the opposite of b divided by 2a. In this case, my b value is 12, so the opposite of b would be negative 12. And then my a value is 2, so 2 times 2 is 4. And negative 12 divided by 4 is negative 3. So that tells me my axis of symmetry, or my imaginary line, is right here along x equals negative 3. Now to find the vertex, I plug that x value in. So my second point here is to find the vertex. Guys, I'm going to want to see this kind of work. You don't have to show every step that I'm showing here, but I do want to see the work that you're doing to get these values. And so to find the vertex, I'm going to take y is equal to 2 times x, but I now know x is negative 3, so I'm going to plug that in squared, plus 12 times x, which again I know is negative 3, and then add 16. I'm going to go ahead and plug that into my calculator just the way I see it. And when I do that, I get an answer of negative 2. And so that tells me my vertex is the point negative 3, negative 2. So I'm going to come over here to negative 3 down to negative 2, and I'm going to plot that point. I'm also going to write that vertex up here on the line where it asks. So vertex is at negative 3, negative 2. Now it asks for two other points, and I can find those two other points. Remember, we had the option of either factoring or using a t-chart. And so I'm going to do both of those, and you can choose which way you like. When I look at the original equation, 2x squared plus 12x plus 16, I notice that there's a greatest common factor of 2, and so I'm going to pull that out first and be left with x squared plus 6x plus 8. And then I'm going to determine if this can be factored. So 8 would have factors of 1 and 8, 2 and 4, and 2 and 4 happen to add up to give me 6. So it is factorable to x plus 2 and x plus 4. And so that tells me that those other 2 points could be the factors. And remember, they're opposite. So the x-intercepts could be at negative 2, 0, and at negative 4, 0. And so I'm going to plot those 2 points, negative 2 and at negative 4. And I see my u start to form there. And so I can go ahead and connect those with a u or a parabola and have that one done. Now, if you chose instead to do a t-chart, we would start our t-chart with our vertex, so negative 3, negative 2. And then we pick two other values that are really close there to the x, so maybe negative 2 and negative 1. And then I would plug those values in just like we did here at the vertex. So I would take 2 times negative 2 squared plus 12 times negative 2 plus 16. And when I do that, I end up with an answer of 0. And then I would do the same thing with a 1. So I'd have 2 times negative 1 squared plus 12 times negative 1 plus 16. And when I do that, I get an answer of 6. And so what that tells me is the point negative 2, 0 is on my graph. Also the point negative 1, 6. So 1, 2, 3, 4, 5, 6 is on that graph. So I can come up a little higher. But not only does it tell me that, it tells me the symmetric points are also on that. So since this is one away on this side, one away on this side would also be on that graph. And then 2 away from the line on this side, 2 away on this side would also be on that graph. And so I could see that parabola form. You could pick different values if you'd like in that T-chart method, but we just want to make sure we're close to the vertex, otherwise they get too big to graph. All right, last one on our practice test here asks us to graph y equals x plus 4 squared minus 3. I notice this one's not in standard form, although I could change it to standard form if I'm more comfortable with that. What I notice about this one is that this one is in vertex form. And so because it's in vertex form, I can very quickly go and write the vertex point because remember, it's right there in the problem. The x is what's attached to the x, but remember when that number is trapped, it goes the opposite way. So our vertex would be at -4, and then the y value is that number that's outside and free. So vertex would be at -4, 3. So I could come over here at -4, -3, and plot my point. I know where my vertex is. I notice that there's no number outside, so it's not going to be upside down. It's not going to be skinnier or wider than normal. It's just going to be a normal graph. But to get some good points that I feel comfortable with, I'm going to go ahead and use my T-chart method to finish this out. So I'm going to start with my vertex at -4, -3, and then I'm going to choose some points that are nice and close. So maybe -3 and -2. Now this one, when I plug it in, it can work. I can do it just the way that I did before. I get y is equal to parentheses x plus 4. So I'm just going to put in -3 plus 4 squared minus 3. I can plug this in my calculator, or I can just kind of think this through. -3 plus 4, that's just a 1. 1 squared is 1, and 1 minus 3 would make that a -2. So that tells me the point -3, -2 is also on my parabola. And then one more point, y equals -2 plus 4 squared minus 3. Again, when I plug that in, -2 plus 4 is 2 squared is 4, minus 3 is just a 1. So that tells me -2, 1 is on my parabola. So that gives me this half of the parabola. And then because it's symmetric, I would have a point here, and I would also have a point here, giving me that other half of the parabola. So my two other points we found were -3, -2, and -2, 1. I could have chosen other points again, but that gives me the values that I'm looking for. All right, guys, I hope that helps. If you've got any questions, make sure you're coming to see one of us before or after school, or you're sending us a message so that we can answer those questions. Make sure you're prepared. We'll talk to you later.